There's a definition for embodied energy. Embodied energy is defined as the sum of energy inputs, fuels, power, materials, human resources, etc., that was used in the work to make any product from the point of extraction and refining materials, bringing it to the market and disposal, repurposing of it. Embodied energy is an accounting methodology which aims to find the sum total of the energy necessary for an entire product life cycle. The life cycle includes raw materials, extraction, transport, manufacture, assembly, installation, disassembly, deconstruction, and or decomposition. Okay. What's going to happen to your building at the end of its life cycle? Does it all go to some landfill over there, or are they toxic materials that you're using? Questions like that, that we need to be asking. Okay. So there are some people, some scientists that are looking at this. It's really complex to figure out exactly how much energy goes into every little product that you use in a building. But here's some examples of some of the materials and how much energy is being used to produce those materials. Aluminum, of course, is real high. Copper is real high. Plastics, of course, is real high. So on and so forth. Brick is pretty low. We live in a brick area. There's a lot of clay soil in Bastrop and Elgin. In fact, the biggest brick companies in the U.S. are now located in Elgin. Concrete, surprisingly, isn't that high. And it's a wonderful building material. Okay, part of our exercise that I give to the students is, okay, we have to design X building. I want you to look first and see Leadership in Energy Efficient Design, which is the standard now for a lot of, at least all public buildings, but even commercial buildings now. One big category that they have is if you get your materials within a 500-mile radius. Now, where did Leeds get 500 miles? It's an arbitrary number. So I tell my students to use 584 miles. Why 584? Because that's the amount of days of the Venus cycle. So if you're going to come up with an arbitrary number, come up with something that ties it to time. Another problem with leads is that it doesn't matter if it's fabricated or if it's natural, they give you the same amount of points. Okay, I think Leeds is going to go through a lot of versions, and one of these days they'll realize that it takes a lot of energy to make the material, not just to transport it, but to make the material. And the less energy that you use for that, the better you're going to be. Now, what is a 500-mile radius? It's an enormous area. This point is based in College Station, Central Texas. And if you get this 500-mile radius, it's a huge area. Huge area. There's all sorts of terrains and natural resources out there. Now, those of us that are based in Central Texas, we're blessed because Central Texas has a wide variety of really good natural building materials. Okay, so who knows how to build with natural materials? Our ancestors know how to build with natural materials. We've forgotten how to do that. We have to go to Home Depot and buy some manufactured product in order to build a house. We don't. We really don't. And so the first thing that I do is show students beautiful examples of buildings that people have had to use what's there. What's there to build their shelters. And some of them are very beautiful. And they're using the material that is right there unmanufactured. So stone, examples of stone, different techniques. For instance, this is a technique where you're not working the stone and you're using a thick grout line. Okay, in order to make that grout line structurally stronger, you chink it with stone. Now that's a technique that comes from ancient times. If you go to Mexico, Central America, and you look at pre-Columbian buildings, they have this little technique where they put stones in the ground, and it's a chinking technique that now you'll see, especially in Mexico, you'll see architects using this technique as an aesthetic. And that's one way that you can make your grout stronger. This is another way of chinking. It's labor intensive. All this is labor intensive. The materials are practically free. It's labor intensive, but anybody can do it. Okay, so if you're willing to put in some time into your building, some sweat equity, you can really bring down the cost. If you talk to an ordinary builder, he says, oh, it'll cost you an arm and a leg. It will cost you an arm and a leg because it takes a long time to do this. But it's something that you can do yourself. So if you have a column of, okay, how much am I spending on materials? How much am I spending on time and labor? You'll see that your materials column cost is very, very low. And there's ways around it. Okay, so there's all sorts of techniques, finishes that you can do using natural materials. You know, the ironic thing about this, that today it is the very wealthiest of our society or the poorest of our society that builds things. The wealthiest because they can afford all that labor, the poorest because they don't have any job, that's why they're so poor, and they just have to build themselves a shelter and they use the materials that they have around. It's all of us in between that are causing so much damage on the planet. Okay, and you can do all sorts of things. You can build a street with stone, and they're very attractive streets. They last a long time. And what energy went into it? Just going and picking the stone. This is an example not too far away. The whole village is made out of stone. It's about 60 miles, less than 60 miles from the Texas border. These are all vernacular ways of building from people that are not professionals. That nowadays, the wealthiest people in our society want this type of building. This is a village in central Mexico, all made out of stone. It doesn't limit your creativity. Stucco. Stucco now, we think of it as a finish. It is a finish, but the reason for stucco was to protect your walls. That's the original purpose of stucco. Now people say, oh, I want a stucco house. Well, when you're building, you have to describe it as your structure. What is your structure? The stucco is not the structure. Stucco is just the finish. If you really want to build out of stone, how about carving your house in a boulder? Of course, when your wife wants an addition, it's another 2 or 3 years. This is modern construction. You're using brick, we live in a brick area here. Elgin is just a few miles away. Stone and brick, it's a great combination. Okay, people say, okay, well, if you build with adobe or red earth or compressed solid block, what's going to happen when it rains? Well, we have a little saying in Spanish. For a good house, you have good shoes and a good hat. It'll last forever. I can take you to some tropical areas of Central America, Mexico, where it rains like the Dickens. You can see a 300-year-old adobe house. Why? Because it's built with good shoes and a good hat. Just very simple, sensible approaches that you don't need a college degree to do it. Here's, I'm going to show you some examples of earth buildings. Here's some chinking here. The adobe block is made with the earth, the adobe, and then you use the same material as your mortar. And you can use all sorts of things for the chinking, and you can get really creative with the chinking. See, this is the same material, the mortar as well as the brick. Handmade, sun-dried, no power tools needed. You can't get any greener than that. And these are cool homes or warm in the winter. Here's some more of that chinking. Whole village is made out of earth. This is in the state of Coahuila, just outside Saltillo. It goes back to the 17th century. It's still standing. It's made out of earth. Earth and trees that you find in that area. Trees, by the way, here in Central Texas, both cedar and mesquite. You go to ranchers, they'll pay you to get it off their land. It's excellent building material. You can even have flying buttresses made of earth. Here we have stone, earth, clay tile. This is in much rainier area than we are here, especially now. Okay, you can go to a wood area. Here we have a wood area. Of course, our concern is that fire is a big hazard. But even your existing wood buildings here, you can clad them in compresso block, and it will resist fire. Okay, you want to use the materials that you have in your area if you're serious about being green. Now that doesn't mean that you have to go primitive. You can be as high tech as possible, as high tech as you want to be. You want coaxial cable. You want all our 21st century gadgets that we can't live without. You can have it. Your air conditioning. You can have air conditioning, but air conditioning is almost like an afterthought. You only use it in those really terrible days. Why? Because you're building this excellent envelope of your house. And not only is it an energy efficient building, you use very little energy to build that. Okay, so it's almost a moral issue. How much are you impacting the planet? And that's what I tell my students. Okay, sure, be as creative as you want to be, but let's see how much your building is impacting the planet. Whole village is made out of wood. Why? Because it's the main resources that you have there is wood. So I show students how people without education, without college education, or even secondary school, can build some very long-lasting buildings. Clay tiles, you might want to go see our booth that we have, A&M has here. We have all sorts of products that are handmade from natural materials that can make some very attractive buildings. This I made it in honor that we're in Texas, a bar somewhere. Why do we go to Europe and places like that, the older countries? We love their buildings. Why can't we build those buildings here anymore? Thatching. Thatching is an excellent roof material. Yeah, it has its downturns in that it could burn, but as far as insulation, it's amazing. So scientists should look at why thatched roofs are so cool. But if you go to some of these tropical countries that have little thatch huts, they're very cool. Why is it? See, our ancestors were a little more aware of the climate because they had to deal with the climate. Here we have a very hot, humid tropical area. You have thatched roofs, and you're building walls with bamboo that allow the ventilation. cross ventilation. How much impact do you think that building is making on the land? Very low. You're always going to have an impact. Those of us involved in creating the built environment, make no bones about it, we are affecting the earth. So we should try to minimize it. You would think that this is in Africa. It's not in Africa. This is in central Mexico. These are corn cribs. It's a combination of thatching, a stone base. Remember your shoes. And it's what anthropologists call wattle and daub, which is you get in branches and then you put in clay soil around it. They're actually quite attractive. It's one little village that's left that still makes it that way. And now they've become a tourist attraction. This is in an area that makes Central Texas in August seem cool. And you walk into these buildings. This, by the way, is the same floor plan that's been used for thousands of years. Archaeologists uncover the housing of Maya sites, and they find the same type of building that's still being built.